So we are going to be deriving the mean of a negative binomial distribution. So to find the expected value of our mean, we multiply x by our function. So we are going to expand from 0 up to 1 and from 1 up to infinity our function. So after expanding, of course this first part dies out because it's multiplied by 0, and then what you're going to do is to expand this part here. So after expanding it, we are going to simplify our new equation. So this is our new expression. So the next step is to take out the x by expanding x factorial. So after taking out our x, this becomes our equation 1. Now we are going to express r minus 1 factorial into other format, and also p power x and also 1 minus p power r. So from the equation, 1 over r minus 1 factorial goes to this, and p power x goes to this. 1 minus p power r goes to this one. So substitute this into equation 1. So after substituting into our equation, remain with this one. So we're going to pull out the constants. So after pulling the constants out, we get equation 2. So we're going to replace x minus 1 with w, and then r plus 1 with s. So w is equal to x minus 1. Such x is equal to 1, w is going to be equal to 0. So we substitute this into equation 2. So after substituting, we get this expression, and we continue to simplify it to get equation 3. So this becomes equation 3. So we are going to, but we know for a negative binomial distribution, this part will be equal to 1. So we express it like this, and then we substitute our 1 into our equation 3 to get the final expression for the mean. So after substituting in equation 3, we find our final expression for the mean of our negative binomial distribution, and our mean is going to be equal to RP out of 1 minus P. This is our mean for negative binomial distribution. So deriving standard deviation of a negative binomial distribution, we know that standard deviation is equal to the square root of variance, and variance is given by this expression. So at this step, we substitute in our mean in this equation, then we find also this first part, then we add it in the equation, then find our variance, then we use that variance, find the standard deviation. So we go forward to find our expression, this one. So we multiply x squared into our function. Then after multiplying, we also we expand this part. So after expanding, we get this one, and in the bottom part, we are going to remain with x factorial for this first part. So we use our x factorial in this bottom part to remove the squared from this, to remove 1x from this x squared. So after taking out one of the x, we remain with our expression here, and then we're going to turn r minus 1 factorial and then p to power x and this one into other forms. Then we shall substitute them back into our equation. So from the above equation, 1 over 1 r minus 1 factorial is going to be equal to this. P power x is going to also be equal to this one, and as p power r is going to be equal to this one. So we substitute them into our equation. So after substituting into the equation, we get this. So we pull the constants out. So after substituting into our equation, we get this one, and we call it equation 2. So we also substitute where there is x minus 1, we substitute it with w, and r plus 1, we substitute it with s. So at x is equal to 1, our w will be equal to 0. So we substitute this into our equation 2, and we simplify it. So after substituting into equation 2, we are going to expand this expression, and then we continue to solve. So after expanding our expression, we get this and we call it equation 3. But for negative binomial distribution, we know that this part up to infinity is the same as 1, adds up to 1, and also this other expression, and also this expression is equal to the mean of w, and we summarize it as this. So substitute this into our equation 3. So after substituting into equation 3, we shall have this expression. We continue to simplify it. Here negative 1 is the same as this one, and then we continue to simplify it to get our expected value of x squared. Also similarly, we know s is equal to r plus 1. That's why we substitute r plus 1 in this step here. Then we continue to simplify. We continue to simplify. Another step, we continue to simplify here and here. So which means our expected value is going to be rp out of 1 minus p squared rp plus 1. So we substitute it into our original expression to find the variance, then the standard deviation. So from our expression, of course, we're going to put this into this, and then we find our variance, then use it to find the standard deviation. After substituting in, we continue to simplify. So after simplifying more, this one dies out with this one, so we remain with our middle part as our variance. So variance is going to be equal to this, so standard deviation is going to be the square root of our variance.